Okay, yesterday we discussed about OSI layers. Any doubts with OSI layers, protocols, port numbers, and application layer protocols, transport layer protocols? Anybody, any doubts? Okay, if there is no doubts, next we'll be moving to difference between hubs, switches, routers. So these are the basic things. You have to know what is hubs, what is switch, what is router. So like as I told, physical layer, you guys know, like we studied 7 layers. Can anybody tell 7 layers? What we studied? Shrija, just you can tell because I don't know, others will not interact.
Application layer,
Yeah,
presentation layer,
yes,
session layer,
yeah,
transport layer,
yeah,
network layer, data link layer, and physical layer.
yeah. Okay, fine. So, what are the examples for physical layer and data link layer, network layer?
In physical layer, we will use hub,
Hub,
and in data link layer, switches,
switches,
network layer, routers.
routers. So, same thing here. So, hub works under layer one device. So, layer one is physical layer. So, that is nothing but layer one device. Hubs is going to work on layer one device, and it is used to connect host devices in a network. So these hubs are used to connect the host devices in a network, and it cannot take a decision because it doesn't have a table. So example, like once we will be studying about switches and routers, they will have some table to store all the informations. But hubs doesn't have any table. Okay, bye. So hubs, it cannot take a decision because it does not have table. See example, what is this table? Once the students are joining still. So hubs. So I told table. This table is going to contain the information from source to destination. This is source and destination. So now this is the PC1. See, I have PC1, PC2, and PC3 and PC4. PC4. So this, you think now this is the PC1. PC1 wants to send the information to PC4. This will be the source and this will be the destination. How they are going to send information based on IP address, all those things. So IP address and all I'll be discussing when it comes to router. Just it is a simple scenario. Just understand why hubs. So now PC1 wants to send information to PC4, whatever the information like files or videos or clips, anything. So PC1 should send to PC4. But in case of hub doesn't have any table. There is no table. There is no table, so it works based on broadcasting. This PC1 wants to send information to PC4, it will send to PC2 also, and it will send information to PC3 also, and it will send information to PC4 also. But only destination PC will accept the traffic and rest will discard the traffic. So same thing here I was trying to explain. It cannot take decision because it doesn't have a table. So, since it cannot take any decision, hub will broadcast the traffic. Now, from PC1 to PC4, it doesn't know that is the source and this is the destination. It will, what it will do, it will broadcast to all the PCs. But only destination, see here, hub will broadcast the traffic to every port except the incoming port. Since it cannot take any decision, hub will broadcast the traffic to every port except the incoming port, and the designated PC will accept the traffic and others will discard the traffic. Only the destination PC will accept the traffic whatever it has sent, but others PCs will discard the traffic. So what is this collision domain and broadcast domain? CD means collision domain, BD means broadcast domain. An area or domain where collision can occur, that is nothing but collision domain. And what is this broadcast domain? An area or domain where broadcast can propagate. Like as I showed the example, only it should send from PC1 to PC4, but it is broadcasting to every PCs. That is nothing but broadcast domain. And next, hubs operates in half duplex. What is half duplex? We discussed in session layer, and I have told you many times. What is half duplex?
Data transmission occurs simultaneously. Sorry, not simultaneously.
Yeah, it is not simultaneous. Two-way communication, it is not simultaneous. Example I gave, walkie-talkie, right? So same thing. This hubs works under half duplex. Because it is two-way communication. Two-way communication is happening, but not simultaneously. That is hubs. And there is a technology called CSMA/CD, means carrier sense multiple access with collision detection, which will detect whether the medium is free or not. This technology is going to test, it is used to detect whether the medium is free or not. So this is about hubs. If your guys are going as a freshers and all, definitely you'll get a question, difference between hubs and router, or difference between switch and router, or can you tell difference between hubs, routers and switches? Your mandatory question. Okay, so this is about hubs. Hubs is simple. Next, coming to switch. How this switches. So next you'll be studying about routers and switches specifically. So far you should know what is switch, what is routers. So switch works under layer 2 device. Layer 2 is nothing but data link layer, data link layer. So switch works under layer 2 device, that is data link layer, and it is used for connecting and enabling communication inside a network. This is used for connecting and enabling communication within a network. And switch maintains a table called CAM table. Mandatory question they'll ask, what is CAM? So switch maintains a table called CAM table which stores information about connected host devices. Okay, I'll give example. Um, so now we are discussing about switches. So I told it is having a table called MAC table. Switches maintain a table called MAC table. MAC is nothing but media access controller. Okay, I was telling switches are layer 2 device. First, if they're asking interview, compare between hub, switches and router. So this one is layer 2 device. Layer 2 device. And switches are maintaining a table called MAC table. What is this MAC means? Media access controller. What it is going to contain? So one second. So they will ask what is MAC table. So first you take the definition. MAC is also known as media access controller, and this MAC is also called as MAC is also called as CAM table. CAM means content addressable memory. See, MAC table also called as CAM table. And this what is MAC table means? MAC tables are unique identifier. MAC table are unique identifier. Okay. So switches are maintaining a table about, see, I told it's having a table. It is source and this is destination. So it will check the source is PC1, from where I should send the data. Destination is, it will see PC4 and it will be in the MAC address like 000 ABC. It will be in the form of MAC address. Like MAC is nothing but media access controller. It is going to maintain a table called MAC table. Okay, then okay, MAC address of connected devices. Hope till here you guys are clear. Just switches maintain a table called MAC table. So maintain table called, okay, I'll just change this. Switches, this is correct, but I'll just maintain a table called MAC table, also known as also known as CAM table. CAM table. CAM is nothing but content addressable memory, which stores information about connected host devices. And what this MAC table contains. So what and all MAC table contains means, which is maintain table called, sorry, what mistake I did, it is called CAM table. CAM table also known as MAC table. MAC table. So MAC is, okay, just leave this. I'll add in next point. So switches maintain a table called CAM table, content addressable memory table, which stores information about connected host devices. So next, CAM table will contain informations. So what this CAM table contains? CAM table will contain informations informations such as, so first it's going to contain the MAC address of the connected device. What is the MAC I told, media access controller. With these are the unique identifier. Each PC will have unique identifier because different pieces will have different MAC address. Because it is the unique identifier, because which is source, which is destination. Every destination cannot have the same MAC address. So this CAM table will contain MAC address of the connected devices. Then it is going to contain interface name and number of the device. Interface name and number means, so like lab I was showing, why I just showed the like last week I guess, in packet tracer I took 2 3 routers, 4 switches and PCs, and there we had a, I'll just show off later, or just shall I know, should I show the example? If you guys tell, I can do, because it's online class, even I am facing a lot of issues. Just tell me, no, you guys know what is interface name number? Just one person
Yes,
just answer.
ma'am. No, ma'am.
You guys don't know what is interface
No,
name and
ma'am.
all, right? Okay.
Yes, ma'am.
You guys install the packet tracer, Cisco packet tracer.
Yeah, ma'am. Install.
Installed. Okay, fine. 1 second. I'll try to get in. I'll just show you guys, because you guys don't know what is those things. You'll not understand. Um, I think there's an issue with my mail. I forgot the password. Okay. So here we are having routers. I'll take 2 routers, 2 switches. This is just simple thing I'm just showing. See, I'll connect this automatic cable. So here you can see G0/0, G0/1, and here also G0/0, G0/1. These all are the interfaces. So these are this MAC address, or the CAM table will contain all the information about the interface name and number. Name is jig, or it will be some other things and all, but here it is jig, and number is G0/0, and here jig 0/1. Which interface is this one, and which interface is this one? It is going to contain all the information. So MAC address of the connected device, interface name and number of the device it's connected, and next it's going to contain the information about VLAN information. So VLANs, which is switching topics, later classes I'll tell. If I now it's very huge topic, I cannot tell. So it is going to contain VLANs information. And next, It is statically configured or dynamically learned MAC address. So what is static and what is dynamic? Static means we are going and configuring each and everything. 1 second. Okay, static means like example, see, I'll go to this Cisco packet tracer. I'm going and configuring everything. I'll go here and I'm going to configure router details. All these other steps later I'll be discussing about all this. So this is, I'm going doing everything manually. This is nothing but manual. Dynamic means automatically it is going to assign all its IP address, interface details, everything is done manually. So this CAM table will contain the information about it is statically configured or dynamically learned MAC address. It is going to store that informations. And next point, CAM table is also called as MAC table. CAM table is also called as MAC table. Okay. Now switches can take decision based on contents in the CAM table. So in the CAM table, it is going to contain like source is PC1, destination PC4. It is going to contain information. Okay, from PC1 to PC1, the information should go there. So it will contain all the information in the CAM table. So if the information is available in CAM table, the switch will unicast. Unicast means from PC1 to PC4 only it is going to send the traffic to the proper device. If the CAM table does not have any information about the destinated device, it will broadcast the traffic. If information is present, it will unicast. Unicast means one to one. Example, I'll just show the. See, now I'll go here. This is PC1, PC2. This is PC3. So switch has CAM table, right? CAM table is going to store all the information about the MAC address. So in this CAM table, if it is storing the information of PC1, now I want to send information from PC1 to PC3. PC1 to PC3. If information is storing in this CAM table, it will unicast one-to-one communication. PC1 to PC3, that will be one-to-one communication. If I want to share from PC1 to PC3, if information is not present in the CAM table, it will broadcast even to PC2, even to PC3. If we are having some more PCs, it will forward to all the PCs. It is going to broadcast the traffic. So this is the CAM table, what I was studying the features. So if information is available in CAM table, it is going to unicast the traffic to the proper device. If the CAM table does not have information about the destination device, it will broadcast. Broadcast means to every devices. And switches is basically observes each and every traffic and learns information from it and store that information in the CAM table. It is going to learn every information it's going to observe each and every traffic, and it's going to learn from every information, and it's going to store the information in the CAM table. So that the next time it doesn't need to broadcast. Okay, so now communication types. We have types like unicast, multicast, broadcast, and anycast. So unicast. So I told switches works based on unicast, because if the information is present in the CAM table, it will unicast. The switches are not present, it is going to broadcast. So unicast means one-to-one communication. Like example, you take WhatsApp. I'm messaging to a particular person specifically. I'm messaging something that will be come under unicast. So multicast, one to a group communication. What is this one to a group? Example, we have a group for CCNA 10:30 batch. So I'm sharing some information in the group. So everyone can access that. So that will be the multicast. Next, broadcast, one to all communication. Next, anycast, it will be one to nearest communication. So a new type of communication introduced in IPv6 called anycast. This is one to nearest communication.
Example for any cast.
One second. Yeah, I'll just write the example. So, like example for anycast. So this is newly launched when I had no idea. So like so anycast. You guys know what is DNS? We discussed in application layer protocols. What is
Yes, ma'am.
yeah? What is DNS?
It converts names into IP addresses.
Names into IP addresses. So anycast addresses usage is in domain DNS. DNS means domain name system or service. So example, like in this scenario, in this scenario, so multiple servers. What is servers? Multiple server. What is servers?
Server is a computer which serves for clients.
Yeah, like it can handle high amount of traffic. Okay, in this scenario, multiple servers is located in different geographical regions. Different geographical geographical regions. Geographical regions or locations. Geographical locations are configured with the same same IP address. So these are acting as replicas. So acting as replicas. Replicas of each other. So when client sends, so when a client, this is a scenario where I'm discussing, for example, when a client sends DNS query, when a client is sending it any kind of DNS query, it is directed to the closest replica. Closest replica. Closest replica of the DNS server based on based on routing decisions based on routing decision made by inter intermediate routers in a routers in the network. So what is this going to help? It is going to redirect to the closest replica. When it is replicating it, sorry, when it is redirecting to the nearest DNS query, we will have improved reliability. Reliability means, what is reliability? Anyone? What is reliability? So
Data to be reached without any failure.
failure. So it will have any like high. Okay, I can mention high improved reliability. There will not be any kind of failure. We will have the high kind of reliability. You guys can note it down or do something, because this all things I have not mentioned in the notes. High improved reliability and faster response times. Response times, as the client can client can connect client can connect to the closest closest available closest available DNS server. DNS server. And it is going to reduce, right, it is going to reducing the risk of failure failure or slow response. So what you guys understood from this? So anycast means one to the nearest. See, unicast means one to one communication. As I go WhatsApp call, hi, I'm sharing to particular person. I'm messaging something. It will be one to one. So multicast to one to group, and your broadcast to one to all people. So here anycast is one to nearest. Example: anycast address usage is in DNS. DNS means domain name server. So we'll take one scenario where multiple servers is located in different geographical regions. So we have different servers which is located in different geographical regions, like one is in US, UK, Australia, different geographical regions, and are configured with the IP address. Okay, are configured with the same. We are configuring with the same IP address, and these are acting as a replicas of each other, because same IP address means it is like replica only. So acting as replicas of each other. When a client sends, any client is sending any DNS query to its query, it is directed to the closest replica. Example: I am staying in Bangalore. I am searching some DNS, like example some website. So it will redirect me to the near, like in Bangalore, where is the server? It will redirect me to the nearest in Bangalore location. If you guys are in Kerala, from Kerala, it will redirect you to the nearest location. Same thing in geographical, like for US, UK. This all are the location, but we are having same IP address, but it is going to redirect to the nearest location. So why it is going to redirect us to nearest location means it is going to have the high improved reliability without any kind of failure, and it will be more faster, and response time, as a client can connect to the closest available DNS server, and this is going to reduce the risk of failure or slow response. So this is about Anycast. Clear with this concept?
Yes, ma'am, understood.
Okay, fine. Okay. Okay, these are the types of communications in switches. Okay, I'll just save this. because I have written example.